So welcome to this chapter of thermodynamics. Let's go through the introduction. When you hear of the term thermodynamics, what does it actually mean? Let's ask ourselves this question. Now, thermodynamics is a branch of physical sciences where it tells us it tells us how heat energy is related to other forms of energy. So this is one of the way in which I would like to define thermodynamics. This is actually all the energy that is related to heat energy. Now we know that energies can be converted into one form to another, but it can never be destroyed. So all types of energy that is present in the universe can be related to heat energy. So if we understand energy in terms of heat, then we are basically dealing with thermodynamics. Now, after that, if you go to the next step, you come to thermal equilibrium. What does this actually mean? Now, what we have to understand is thermal equilibrium. When we hear of the term equilibrium, we mean that there is no change with respect to time that is taking place. Equilibrium, for me, I define equilibrium as no change with respect to time. So if there is no change with respect to time, then we know that this is in equilibrium. That is thermal equilibrium. So in mechanics, we know that when there is no net external force, this is for mechanics equilibrium. But for thermodynamics, this is how we define. That is the characteristic, that is the system do not change with respect to time. Now, another thing that we come across is your adiabatic wall. Adiabatic wall. So, what are the physical significance of adiabatic wall? Say suppose you have two containers, each having different temperature. Now, even though they are connected, but still this for this system it's in equilibrium, and for this system it's in equilibrium. That is, no amount of heat energy is transferred from container A to container B and vice versa. There is no transfer of heat energy. So if there is no form of heat energy, or we can define in a more precise way that there is no transfer, or there is no transfer of energy. So if there is no transfer of energy, then what we know is that it's a adiabatic wall. Yes, adiabatic wall. This is known as adiabatic wall. So if there is a wall which stops the movement or transfer of energy, is known as adiabatic wall. So now if this adiabatic wall is replaced by diathermic wall, what happens then? So this two container, this is T2 and this is T1, and this is diathermic wall. This wall is diathermic. So what happens is there's an exchange of heat, or that you can say there's an exchange of energy that takes place, and finally these two containers come into thermal equilibrium. So diathermic wall, you can classify or you can explain diathermic wall as the wall which allows the transfer of energy. allows transfer of energy. This is what you know as diathermic wall. So these are some of the concepts that we need to know initially in order to proceed with the chapter of thermodynamics. So the first thing comes the zeroth law of thermodynamics. So let's see what happens in the zeroth law of thermodynamics.